Hey, I just wanted to get you guys a little bit started on functions, and some of the notation that you're going to see in the class. So a function is if I have a three-element set and a two-element set. A function is a particular arrangement of arrows from the thing on the left to the thing on the right. That's all a function is. Now, there's a lot of ways to arrange arrows between two sets, but functions are a particular way of arranging arrows between two sets. The idea is if an arrow has a tail and a head, the idea with functions is that one, there is exactly one there's just one. There's exactly one tail on each item of the left set. Okay? That's what makes it a function. So, exactly one tail on each item of the left set. That's a function. Now, like I said, there's other ways of arranging arrows between two sets. And you should take a discrete math class to learn about them, or watch discrete math classes on YouTube to learn about them. That's basically what a function is, fundamentally. So, let me see here. I'm going to erase. Take a screenshot now if you want it. Erased. So, the notation that we're going to see a lot is if I have a function f that's defined to be equal. So listen to my words and look at the symbols I'm writing. F is defined to be equal. So this means defined to be, and it's going to be x maps to f of x. Okay, so we have maps to, and this is a variable. It's a variable that is scoped, it is bound, and scoped, okay, to the body of f. From A into B, where A and B are sets. So this is the complete specification of a function. Okay, you'll see some expression that'll be some body of the function, but this is the complete expression. Now A and B are sets, so A, B are sets, right? And this arrow is like the set level of like mapping, basically. So if in the example I gave earlier where there's a three-element set and a two-element set, well, it's basically like A into B, right? And the map arrows map the elements. I call this a map arrow, the thing with the little, this thing. It's a map arrow. I shouldn't have, let me undo. It's a map arrow is at the element level, and just a regular arrow is at the set level. So the basic idea is, if you think about it as like resources, think about it as like whether or not I have items from sets. So like we know that like items live in sets, but like we don't know if I have an item from a set, right? But if I have an item from a set, and if I have a function from one set to another, then I can construct an item from the set on the right. That's kind of the idea. That's kind of the idea. But let me give myself more room. Let me erase that real quick. So A, B are sets. Now what you do is you get X is in A, okay? And F of X is in B. And the usual notation is actually with parentheses here. You'll mostly see it with parentheses here. But this is fundamental. This you really need to know for success in the class. Yeah, that's what I want to say about functions and sets. So I'm going to continue, actually. I'm going to continue the video and talk about programming because I'm a programmer. And if you're a programmer, I can give you some extra intuition. And if you're not a programmer, I don't know how much this extra intuition will help you. But we can specify we can go by analogy here. Actually, you know what? I'm just gonna erase down below. I'm just gonna erase down below. I'm gonna leave the top part here. And let me try to clear out more of these. Okay. So what we can do is we can talk about Python. Now Python, a function, if you know any Python, it's def f takes an x and it returns some expression. So let's say we're talking about x plus 1, the increment function. So you can see the analogy. The return is basically what goes to the right of the map arrow. Goes to the right of the map arrow. So if we can make this our example. The body of the function, is just return x plus 1. Right? So these are identical ideas. These are identical ideas. Now, what Python doesn't have is it doesn't have like static typing, but it does have type hints. So if you're not in Python 2, if you're in Python 3, at least 3.4 actually, you can actually give a type hint. So I'll say that this is increment defined on floats into float. So this isn't really standard Python, but basically A into B, right? This is A into B. So instead of A and instead of B, I can write, oops, it does this sometimes. I can write float into float. Right? So this is the increment function in Python. Now, if you know any Java, let's see, Java method. Let's see what we find. See, that's public static void, and void is having no return type. What I'm trying to do is here. This is a good example. This is a great example, in fact. Public static int return type, right? Parameter list, and the parameter list comes with input types. So what would this be? What would this be? So take a minute to pause the video and see if you can translate this method signature. See if you can translate this method signature into this notation. So take a pause and do that. So this was a complicated function body. with conditionals and everything, which we can do in math some of the times. Sometimes a function body will be like unmathematical, particularly in Java. But other times, we're just going to go back to this and just call the body f of x. And this was int cross int into int. This, because it take two ints as parameters. See, these are, this x, it would be x, it would actually be x comma y, and in a tuple is the notation used. Takes the tuple xy into f of x comma y from int cross int into int. And what that means is that your parameters x and y, your parameter tuple xy is an element of int cross int, and f of x comma y is an element of int. That's what it means to have. So this is a return type, and this is parameter type. And this is parameters. It's sort of like that. That's basically the idea. So get to know this notation. A function f is defined to be equal to parameters mapping to some body, some expression, from the parameter type into the return type. Now I'm saying type, but usually what we'll be dealing with is sets, right? In the linear algebra course, you're doing this with vector spaces. But we'll get into that. But like I said, you know, with the sets example, just rewind the video, go back to the sets example. Yeah, usually these will be sets and not necessarily types. But yeah, that's all I wanted to talk about in tonight's video. So I just wanted to get you guys started. And I'll see you later.